So your quiz is just on 4.3. You got change of base formula, which you need to know, condensing and expanding log expressions. So the first thing that we're going to look at is the change of base formula, and we're just simplifying these log expressions using the change of base formula. So you want to remember, this isn't going to be given to you, but remember that this is going to be the log of the big number, so like the whole number part, over the log of your base. And you'll use your calculator for these. Round to 3 decimal places. So for number 1, you're given log 3 of 61. You can't raise 3 to a power to give you 61. So we're going to take the log of 61 divided by log of 3. So we use our calculator. Log 61 over log 3. That comes out to 3.742, rounded to 3 decimal places. For number 2, you have log 6 of 216. Now this one does work out evenly. However, if you didn't know that, you could use your change of base formula and do log of 216 over log of 6. And your calculator would just give you 3, because 6 to the 3rd power is 216. So the directions for your next 2 questions are actually for number 5, 6, and so on. So 3 and 4 are both using the change of base formula to simplify. So for 3, you have log 11 of 5. So this one, bless you, you're going to just do the log of 5 divided by log of 11. And this gives you 0.671. For number 4, again, we're using the change of base formula to simplify. You have log of 346. So your base here is not given to you, so it's understood that it's 10. So you could just use your calculator and do log 346, because that button on your calculator is given as the base of 10. Or you can use your change of base formula. So that's log 346 divided by log 10. Rounded to 3 decimal places, you should get 2.539. For your next section, you are using those directions above 3 and 4, and you are expressing as a single logarithm and simplifying if possible. For number 5, you have log 4 of 3 plus log 4 of 15. Addition can be represented using multiplication. So we're going to rewrite this as log 4 of 3 times 15. The 3 times 15 is 45, so that's just log 4 of 45. 4 does not raise to a power to give you 45, so you're going to leave it in this form. For number 6, you have log 7 of 13 minus log 7 of 4. You're going to keep the log 7, and you're going to rewrite your subtraction using division. So it's just going to be 13 over 4. So log 7 of 13 over 4. For 7 and 8, you're using the same instructions as the ones before this for 5 and 6, and you're condensing these. So for 7, you have log 5 of 10 plus log 5 of 13 minus log 5 of 4. Because the first 2 parts are in parentheses, that's going to be on the top of your fraction. So you'll use multiplication between the 10 and the 13, and you'll use division with the subtraction. So you're going to have log 5 of 10 times 13 minus log 5 of 4. Bless you. Your 10 times 13 gives you 130. So that's going to be 130. Log 5 of 130 minus log 5 of 4. You are now going to use division to represent the subtraction. So that's going to give you log 5 of 130 over 4. You cannot simplify the 130 over 4. I mean, you could to give you, let's simplify it. They're both divisible by 2. So that's going to give you log 5 of 65. over 2. For number 8, you have log 6 of 2 minus log 6 of 9 plus log 6 of 3. Simplify the addition first, so multiply your 9 and your 3. This is going to give you log 6 of 2 minus log 6 of 9 times 3, which is 27. So log 6 of 2 minus log 6 of 27 will then simplify with division to give you log 6 of 2 over 27. For 9, you have 1/2 times log 2 of x plus 3 times log 2 of y plus 8 times log 2 of z. This 1/2 is going to become the power on x, the 3 becomes the power on y, and 8 becomes the power on z. So that's going to give you log 2 of x to the 1/2 power plus log 2 of y cubed plus log 2 of z to the 8th power. All of your, or here, how about this first? This power of 1/2 has to be represented using the square root. So this is the same thing as saying log 2 of the square root of x plus log 2 of y cubed plus log 2 of z to the 8th power. So now all of your addition can be rewritten as multiplication. So you have log 2 of the square root of x times y cubed times z to the 8th power. In standard form, this was just going to be log 2 of y cubed z to the 8th power times the square root of x. Remember, your radicals always go to the end. For number 10, you have 1/2 times log 4 of x minus 3 log 4 of y plus 6 log 4 of z. You're going to first simplify those numbers in front and make them powers on the y and the z. So that 3 becomes the power on y, the 6 becomes the power on z. So it's going to give you 1/2 times log 4 of x minus log 4 of y cubed plus log 4 of z to the 6th power. From here, simplify your subtraction and your addition. Subtraction means divide, addition means multiply. So this is going to give you 1/2 times log 4 of x over y cubed z to the 6th power. From here, that 1/2 has to become the power on the parentheses. So you're going to have log 4 of x over y cubed z to the 6th, all raised to the 1/2 power. Represent that 1/2 power using the square root, and you are left with log 4 of the square root of x over y cubed z to the 6th power. For the next part of your review, you are expanding these expressions. For 11, you have the log of x to the 4th power square root y over 3z to the 6th power. Now, look at the first thing. You don't have a base here, so it's understood that it's 10. You can just leave it as log throughout the time that you're working on it. You do, however, have subtraction and multiplication in this. So we are going to represent the division using subtraction first and then go from there. So this is going to give you log of x to the 4th power square root y minus log of 3z to the 6th power. Now you have multiplication next with both parts of this on both sides of that subtraction sign. So you have multiplication here and multiplication here. The 3 in front of the z is being multiplied by it. So you have to rewrite this using addition between both of those parts on each side of that subtraction sign. So you're going to have log of x to the 4th power plus log of the square root of y minus log of 3 plus log of z to the 6th power. The square root of y is like saying y to the power of 1/2. These powers have to move to the front of your logs. So that 4 with the log x to the 4th power is going to become 4 times log x. The power of 1/2 on the y is going to go to the front to give you 1/2 log of y. Then you have minus log of 3. And then the 6 at the power on the z goes to the front to where you have plus 6 log of z. So altogether, you have 4 times log of x plus 1/2 log of y minus log of 3 plus 6 log of z. For 12, you have log 3 of x to the 6th power, y to the 9th power, cube root z. Now, you have multiplication with all of this, but I'm going to first rewrite the cube root as a power. The power on that z is 1. The index is 3. So that's the same thing as saying z to the power of 1/3. So we have log 3 of x to the 6th power, y to the 9th power, z to the power of 1/3. From here, we're going to separate all of this with addition because of the multiplication. So you have log 3 of x to the 6th power plus log 3 of y to the 9th power plus log 3 of z to the power of 1/3. Lastly, your powers are going to move to the front of each of those expressions that they're attached to. So you have 6 times log 3 of x plus 9 times log 3 of y plus 1/3 log 3 of z. For 13, you're given log 7 of the square root of x times y squared all over w to the 4th power, z to the 5th power. From here, you are going to first rewrite the square root as the power of 1/2. So you have log 7 of x to the power of 1/2 y squared over w to the 4th, z to the 5th. Then you are going to rewrite the division as subtraction. So that's log 7 of x to the power of 1/2 y squared minus log 7 of w to the 4th, z to the 5th. Next, you have multiplication. So rewrite that using addition. So it's going to give you log 7 of x to the power of 1/2 plus log 7 of y squared minus log 7 of w to the 4th plus log 7 of z to the 5th. All of those powers are going to move to the front of each of those expressions. So this is going to give you your final answer of 1/2 log 7 of x plus 2 log 7 of y minus 4 log 7 of w plus 5 log 7 of z. With this number 14, I'm going to start this a little, I'm going to rewrite your 5th root as the 1/5 power, because your base, or that power on x is 1 and the index is 5. So that's going to give you log 4 of y cubed times x to the 1/5 power times 2x minus 1. So now we're going to rewrite using addition for each of these parts. So you have log 4 of y cubed plus log 4 of x to the 1/5 power plus log 4 of 2x minus 1. Powers go to the front of each of those expressions. So that's leaving you with 3 times log 4 of y plus 1/5 log 4 of x plus log 4 of 2x minus 1. For number 15, you have log 3 of 4x times the square root of 5x plus 7. So again, I would rewrite the square root as the power of 1/2 on that 5x plus 7. So you have log 3 of 4x times 5x plus 7 to the power of 1/2. So from here, rewrite using addition. So that's log 3 of 4 plus log 3 of x plus log 3 of 5x plus 7 to the power of 1/2. You have one power here that needs to be moved, so that 1/2 needs to go into the front of that log 3. So that's going to give you log 3 of 4 plus log 3 of x plus 1/2 log 3 of 5x plus 1, or sorry, plus 7. For number 16, you have log 2 of 3x times 4y minus 1 over 5 times the cube root of z squared. I want to rewrite that cube root of z squared differently first. So that's going to give us log 2 of 3x times 4y minus 1 over 5 times z to the power of 2/3. So that 3 just becomes the denominator on that 2. Okay, so from here, we're going to rewrite our division using subtraction. So it's going to give you log 2 of 3x times 4y minus 1 minus log 2 of 5z to the power of 2/3. You have multiplication happening here between the 3 and the x, so you'll represent that with addition. Same thing with between the x and the 4y minus 1. You also have multiplication happening between the 5 and the z to the 2/3 power, so you represent that with addition. So it's going to give you log 2 of 3 plus log 2 of x plus log 2 of 4y minus 1 minus log 2 of 5 plus log 2 of z to the 2/3 power. The power on the z is going to have to go to the front. So that's going to give you log 2 of 3 plus log 2 of x plus log 2 of 4y minus 1 minus log 2 of 5 plus 2/3 times log 2 of z.